Hello, Dr. Rauscher here. Let's go through another problem. All right, so classify the following as an element, a compound, a homogeneous mixture, or a heterogeneous mixture. All right, so we want to find out whether it's an element, a compound, a homogeneous mixture, or a heterogeneous mixture. So first thing I guess we can do is just decide whether it's going to be a mixture or not, right? All right, so when we think about liquid gallium in a vial, is this a mixture? No, it's just gallium and it's pure gallium and it's just in a vial. So that would be, well, since gallium is an element, that means that this is just going to be an element. Okay, sodium chloride. Well, it doesn't say whether this is a solid or a liquid or whether it's aqueous in a solution. If this happened to be sodium chloride in solution, so for instance, this was aqueous, then we would say that this would be a mixture, right? Because it would be mixed with water. But that's actually not what the question says. It doesn't say that at all. So if we're just talking pure sodium chloride, either a solid, liquid, or a gas, this is going to be a pure uh, compound in this case, because sodium chloride is not an element. Sodium is an element, chloride is an element, and so sodium chloride is a compound. All right, salt water. Well, there you go. Now we have our sodium chloride dissolved in water. Okay, and then this would be a mixture of water and salt, and that mixture is a homogeneous mixture. When you look at a glass of salt water, or whenever you look at water that has salt dissolved in it, you can see through it. There's no difference in the phases of the different compounds that are mixed together. So this is a homogeneous mixture. All right, homogeneous mixture. Orange juice. Now, I think everybody knows that orange juice is not a pure solvent or a pure element or a compound. It's a mixture of things, right? There's water in there. There's some citric acid. There's all kinds of different things. And because you can't see through it, that means that there are some components of this mixture that are in a different phase than other components. So liquid, the water, for instance, is a liquid. And in the saltwater case, the sodium chloride that's dissolved in that water is in the same phase. It's aqueous. It's in the liquid form. But we have in orange juice, we have little pieces of particles that are floating around in there, and they're solid. And those particles meaning that they're not in the same phase. And so this would be a heterogeneous mixture. All right. Now, hydrogen peroxide. Okay, hydrogen peroxide is H2O2, and that is a compound, so not an element. So we know it's not an element, which is labeled as being 10% hydrogen peroxide. Well, if it's 10% hydrogen peroxide, that means it's some percent of something else. Actually, hydrogen peroxide that you buy in the store is 10% hydrogen peroxide. The rest of it is water. And if you have a glass of this, other than the bubbles that you might see in the solution, it's going to be clear and colorless. It's going to be, you'll be able to see through it. So this is a homogeneous mixture. All right. Now let's look at each of these different pictures and decide what each of those are. In this case, we have a picture of a bunch of different compounds, right? So here's a compound of 2 pink balls and 1 yellow ball. We got like 4 of those. Okay. We have these other compounds here. This is an element, looks like a diatomic element of 2 sort of pink purplish looking spheres. And then we have another diatomic element. So these are elements. This is a compound, but altogether we have a mixture. Now, the little, I don't know if you can see this very well in the video, but there's a little bit of blurring around the edges that make it look like each particle is moving quickly. You can see a little better in this one, maybe not. But in any case, they're not very close together. They're not stuck together. So this looks to me like it's in the gas phase, right? And it is a mixture. And because everything is all over the place, there's no separation of maybe the pinks on one side, the greens on the other. This would be a homogeneous mixture. Here we have a pure element. It's all just one compound, this blue element right here, whatever that is, and it happens to be in a gas phase. So this is not a mixture. This is just an element. Now over here, we have 5 of these little guys. They are blue atoms connected to some black atoms. Okay, so this is a compound. And in this, vessel that we have here, all of them are the same. So this is not a mixture of anything. It's just these compounds. And again, it looks like it's in the gas phase to me. So we're just going to call this a compound. All right. Here we have a mixture again. But what we have is we have some red elements that are in the gas phase, or I suppose it could be liquid, but they should be closer together if they were liquid. Anyway, they're in the they are in a completely different phase than these black ones. These are definitely a solid. Okay, and these look like they're a gas to me, which means that they're in different phases. So this then is a heterogeneous mixture. All right, that's it. Thank you very much. Have a wonderful day.